We are going to be graphing quadratic equations. And to understand how to graph quadratic equations, there are two skills that we're going to be using. The first thing is, skills that are going to help us are completing the square. So knowing how to complete the square and put a quadratic equation into vertex form is going to be extremely helpful. And the second thing, once we have that in vertex form, we'll be able to utilize translations and reflections. To actually do our graphing. So for each quadratic function, we are going to find these 6 items. We're going to find the vertex. We're going to find the axis of symmetry as an equation. We're going to determine whether or not we have a maximum or minimum. Then once we determine whether or not we have a max or min, we're going to determine the value of that maximum or minimum, along with the input for the maximum or minimum, and the x and y intercepts as ordered pairs. Then we will graph it, and sometimes we will need to add additional points to make our graph accurate. Okay, so let's get started on our first example. We have y equals x squared minus 2x plus 3. Our first step is to complete the square. To put into vertex form. So we want to put this into vertex form. Take this, I'm just going to resize it, shrink it up there. That's our first step, is to complete the square to put it into vertex form. So I have y equals x squared minus 2x. I'm going to put a little addition sign in a segment to add so that I can complete the square. And then I'm going to put the plus 3 on the outside. So everything that I've written in gray is the same exact equation. I've just kind of rearranged things a little bit. Now what I'm going to do is I'm going to, in blue, complete the square. Half of 2, we look at the linear term, half of 2 is 1, 1 squared is 1. Because I added 1, and now I changed the value of the equation, I'm going to subtract 1 on the outside of the parentheses to keep things balanced. So I add 1 to complete the square. I'm going to subtract 1 to undo it. So over here, I'm going to write down whatever, not when, whatever we add inside, actually whatever we add, because it's not necessarily inside. Whatever we add, we need to subtract on the same side of the equation to zero it out. So we added 1. We need to subtract out that same 1 on the same side of the equation to zero it out. Our goal is to get this into y equals a times the quantity x minus h squared plus k, because HK will be our vertex. Okay, so we want to zero that out. Now that we've completed the square, y equals x minus this 1 right here drops into that parenthesis, x minus 1 squared, quantity squared, plus 2. 3 minus 1 is 2. Now, that's the whole idea of completing the square. If I were to take x minus 1 quantity squared and multiply it out, if I were to take x minus 1 times x minus 1, I would get x squared minus 2x plus 1. That was the reason for adding 1, so that we could complete that square. So now we have our vertex form. This is very important. This is our vertex form. And now we can determine our vertex, our axis of symmetry. So our axis of symmetry as an equation, whether or not we have a max or a min, the value of the max or min, and the input to get the max or the min, whichever one it is, x-intercepts and y-intercepts. So we have a vertex of 1, 2. We have an axis of symmetry of x equals 1. So let me show you. We've got our vertex of 1, 2. So write 1 up 2. That's our vertex. Y equals a times x minus h squared plus k. Our a value is 1. HK is our vertex. You'll recall from Algebra 1, when a is greater than 0, the parabola opens up, which means we have a minimum. When a is less than 0, the parabola opens down, which means we have a maximum. Because a is 1, and that's positive, this parabola is opening up, meaning we have a minimum value. The value of the minimum is your y value, the lowest y value. Minimum equals 2. And the input to get to the minimum is a 1. Because it opens up, we have no x-intercepts. And our y-intercept is the value of y when x is 0. So I go back to my original equation, because that's the easiest one to do the math with for this particular computation. Put a 0 for x, and we get a 3. So 0, 3. I'm going to go back and I'm going to draw the axis of symmetry. The axis of symmetry is a vertical line, a vertical imaginary line that shows us our symmetrical portion of the graph. So you might have learned different ways to graph this in Algebra 1. I'm going to put a 3 in. 1, 2, 3. I'm going to put a 3 in to the equation and determine an output. You can put a 3 into either equation. You can put a 3 into our vertex form, or you can put a 3 into the original standard form. When you put a 3 in, it's like creating a table. When you put a 3 in, you get a 6 out. 1, 2, 3, 4, 5, 6. And we're going to reflect that point over. Then I'm going to put a 4 in. When I put a 4 in, I get an 11 out, which is just off the grid, but that's okay. I'm going to kind of eyeball it. And then I'm going to draw my parabola. And that is the graph of our parabola. So we've shifted this using our translations. We've shifted right 1, here's our right 1, up 2. So we took our standard graph and we took that point and we shifted it right 1 and then up 2. And then we drew our parabola. We're going to graph some more of these in the next videos. And the next ones are going to, remember this is college algebra, so you've seen this in Algebra 1, you've also seen this in Algebra 2, you've seen the completing the square as well. So we're going to go a little bit faster on the next ones. That'll get us pretty comfortable, hopefully, graphing all sorts, because we'll be able to do more examples. We've got a couple more headed your way.